Hello, welcome to another interesting demonstration by EMITE. Today we have here an outstanding combination. We are going to test two downlink card components plus UMA plus Mimo over the air with the new box from EMITE, the MT8821C, which you can see here in combination to EMITE PropSim FS8 channel emulator, which you can see here, and EMITE E500 reverberation chamber here. The new box from EMITE has not yet been combined to test over the air, so this is a worldwide prime thing that we're seeing here today. We're going to run a test for throughput in downlink with 64 QAM and UMA, so quite of a demanding test. For that we have the software of EMITE here in the computer, so you can see in other videos by EMITE, this is very simple to use. We select the active Mimo OTA option and then simply import a file that we have ready for the test. We're going to test the combination of band 4 and band 17 in LTE FDD. This one here. And simply once everything has been set, we can, if you want, check the properties of what we're going to test here by clicking on properties. This is a throughput measurement. It will use a specific combination of connectors for both primary component and secondary component in the eNode B. You can also set the power control specific to a standard for CTIA or 3GPP or a carrier specific combination, including the power level for uplink or downlink, and including, of course, if you want, also audio white Gaussian noise. The connection setup here tells us that both primary and secondary are in open loop spatial multiplexing mode with an RB of 50. That means basically 10 MHz bandwidth and MCS of around 20, so that's 64 QAM, and that's for primary and secondary component. Here in band 17 you can select the channels, the bandwidth, everything can be set using the software from EMITE. Then if you look into the throughput settings that we're going to see today, we're observing that we will use the downlink power average inverse throughput with a specific number of frames per point and a cap to cut the end of the curve. It will go from -90 all the way down to -120 dBs per 15 kilohertz, so that's RS EPRE values. Then the channel that is going to be emulated, the channel model that is going to be emulated in EMITE, it's a UMA, isotropic UMA fading. You can see here in the software that we detect basically that we have an E500 chamber, Platinum Ritsu MT8821C, eNode B, and the EMITE PropSim channel emulator. The calibration is being already preloaded for the file that I just loaded. It has all the models for all the bands and the primary and secondary. We're going to test a stepwise manner, so it will be a number of samples, individual curves that then will be added and averaged to get the final value, giving a total number of set frames per step power of 50,000. Okay, so we just have to run this measurement here. The first thing that the software does when pressing run here is to configure all the external equipment like the EMITE. So we can see here that the auxiliary outputs are being configured. Also the channel models are being loaded into the channel emulator, and basically that configures everything for the network that we want to test. Once the configuration has been finished, the software will tell you the connections that you have to make sure that all the cables and RF connectors are correctly placed. Basically here you have the eNode B, you have 2 RF connectors per carrier, so you have 4 outputs from the eNode B going into 4 inputs of the channel emulator, and the channel emulator outputs 8 cables that goes that go into the chamber. And in addition to that, you have uplink for control going directly from the chamber to the e-node B. So if that's okay, you say that's ready, and then first thing you have to do is to attach your device under test. In this case, we have one of the latest devices in the US market, and this supports carrier aggregation for those two bands that we're going to measure. Attachment is one of the simplest things that you could do in the market. You just open the door, switch on the device, just put it on here, and you see on the screen of the e-node B that there you go, you have the device already attached for both the primary and the secondary component. We can go into remote, from remote into local, and then check here for, I don't know, the primary component. We can check the downlink RMC part. We can see that it's connected here. We can just replay how the connection took place for a minute. And then you will see also, if you want to check that secondary carrier component, there is a summary on top of the screen that tells you the main parameters, but you can also, browse through them in the screens. This is the Anritsu box has a touch screen that is quite useful. So that's attached. That's it. It's done. It's very simple. And then you only have to close the door and get the measurement run. So for the measurement, it would be useful to go into the throughput window here. We just press run in the software, and the measurement starts. You can see that the channel model is being emulated. That you can double check not only in the LEDs on the screen of the EMITE PropSim emulator, but also if you have a monitor, you can check that the channel model here, it's emulated. You can see the green scale here, that the CIR positions are being emulated, and in fact you can check all the different ports being run at the time. So basically we are starting to measure already, and then you can see in the screen of the Anritsu the first throughput measurements being taken from the device. You can monitor that in text mode, as you can see here, or in display mode, and that's graphically more attractive, as you will see how a single measurement it progresses. So we have 3 sets of curves in the screen. The light green has been the first sample measurement for the secondary component. That's band 17. It's to the right hand side of the screen, so it means its behavior is a lot worse than on the other, the primary component in band 4. That is the dark green, and then the overall is the top, the darkest green curve that gives you the overall throughput, roughly about 70 megabits per second. And then what you see in different colors and moving as time progresses is the currently measured sample for throughput. So all 3 components are being measured, and they evolve in time, and to get a sample curve, and that sample curve is averaged with the existing ones to get the final curves for the measurement. Now this will go for something like 5 minutes, 5 to 7 minutes for this measurement to run, and until you get all the curves, you will not get the accurate result. So you have to get all the samples measured and then average them out to get the accurate results using the reverberation chamber. So this is it. We're measuring 2 downlink carrier components for band 4 and band 17 in LTE FDD. We're using a channel emulator for isotropic UMA and an Anritsu MT8821C that, as you can see, works quite nicely with our system, and it's quite useful for this. So once again, within the software, you can monitor this remotely from your desktop somewhere up in the offices, or you can also control the percentage of the measurement that is being performed so far, and that gives you an estimation of the time that is to finish, as well as you can obviously at any time pause the measurement and perform some other things you want to do and then continue that, or you can check the properties of your measurement while you're doing the measurement. That's done in parallel. And in fact, you can see here that the basic settings are carrier aggregation for band 4 in primary. The channel is 2175 with 10 megahertz of bandwidth. We're testing UMA, isotopic UMA, and then the specific parameters that were set are laid out here, both for the primary and the secondary component, which is band 17. Here you check basically everything that can be set. You also have access to the throughput settings, so what is the value. For example, if you want to set a specific sensitivity value you are searching for, in this case we call Mimo throughput sensitivity to 70% of the maximum throughput, and then the software will search for that value and provide that as a result of the measurement as well. And also whether you have specified in your software a pass or fail criteria. It is also possible to set a criteria and provide a report, as we will see when the measurement finishes. At any time you can also save your setup for future use, hide the properties, and show a summary of your measurement. Now this is a single measurement that we're running, but in this particular software and combination of hardware equipments, you can run a batch which has an automated handover process and call drop handling process, which allow you to measure different technologies, different bands, different figures of merit. So if you have a long list of measurements to be run automatically, you can monitor how those measurements are progressing from this summary window, and even look at the results that are appearing on the screen as these measurements are being taken. So again, we are seeing here that curves are starting to be very smooth now. As you can imagine, the more samples you take, the more accurate the result is, but there is a point in which the average of all those curves change very little as you add more curves, and this is what we can see right now that is happening here, is that you have a clear secondary component here that is not acting quite nicely, but that's compensated somehow by the primary component in band 4, and then the overall, you can see that the overall curve here follows the combination of the two components, and that's what it's a typical behavior in carrier aggregation. You have quite nicely a very common slope here for the two bands, and then the overall starts dropping as the secondary drops, and then catches the primary component when the secondary is nearly done. So we are just going to let it finish for some time. We can see on the screen in the video how everything can be monitored on this complex OTA system. And when the measurements are finished, we will have a look at the report that is automated also by the software. Okay, this is about to finish. I believe we have last curve here, and after the last curve we will be able to save the results and see the report of the software. There you go. Finished. Now we are given the option to save. We can of course provide some information on the device to be saved on the report file. Some of this information is obtained from the eNote B directly, so it's just placed here. And we can also save the summary of the measurement as well here. Let's save it as test 1. And then we can either repeat this measurement, create a new measurement, or simply open up the report in HTML protected format. As you can see here on the screen, you have here the date and time at which this was done, the instruments connected to our system, the device information that you introduced or was obtained by the eNote B, a summary of the results of your measurement. We have obtained here an MTS of minus 99.72 dBm per 15 kilohertz, and then the details of the throughput measurements. And you can see here that for each of the RS EPRE power values, we have a downlink power inverse throughput for the primary, the secondary, and the overall result, which gives you sensitivity values for all 3 different components, the overall, primary, and secondary. And at the end, you also have the graphical curve that shows the device performance on that combination and modulation schemes. So this is it. It's been making Mimo measurements simple. Thank you very much for your attention.